Hey, so in the last video we started working on this breakout game and we created the pad and made it move to the right. Let's just do it again. So if I press the play and run the game, you can see it moving all the way to the right. And we started to work with code and for making it move. And let's do something else. So let's go back into the code. And we have here the code that makes it move, right? We have it's taking the position from transform.position. We add 005 on each frame, and then we set it back to the transform.position in a way that we put it inside the new vector3. Okay, vector3 object that has the next x, which is the new x position. It takes the same y that we had in the last position and the same z. So this is quite nice, and we make it move from the middle to the right. But let's try to control it a bit. So first of all, anytime that you see a literal number inside your code, it's probably best to change it into a variable, which also lets us do other things, like changing it and changing the way the game operates in a much easier, simple way. So how do we do that? So there are two ways to create a variable that we can actually see inside the Unity and change it. The same way that we can change the transform.position from Unity, we can see other things we can change. So let's have a look in Unity. And if we look here, we see the transform right. We've seen that we can change the x from here. Okay, and we can change other stuff. And we want something to, we want a variable to change the speed that it moves. Currently we use 0.05. So let's add the ability to change it. And how can we do so? So the simplest way is just calling a public variable. Public means that it can be reached from any place in the code. Any part of the code that has an access to an instance of this object can change this variable. But in Unity it actually has some additional feature, because if I create public float, for example, and I call it speed x, I can actually change it from Unity itself. So if I look now in Unity, okay, and it'll reload the script. One sec. Okay, you see here it's yellow. I have to save it, and let's do it to save it automatically. So if I go back to the Unity and reloads the project, we see here that now I actually have this speed which I can change here, right? I can just drag it the same way I did with the x here, the position. I can actually change the speed. Now this wouldn't change the speed of the pad yet. Okay, look, even if I put it at 14 something, if I run it, it will look in the same way, moving on the same speed. Why is that? Now the reason is because we haven't used it. Okay, we created a code to use it. We created a variable here, but we're not using it. We're still using the literal 0.05 here. And this is the kind of mistake that usually programmer does a lot when they're starting out. Okay, they think they made a change. They make an assumption. They make an assumption that, here, I created a variable that should change the speed, so it should just work. But if we're not using it, and we're not using it here, then it wouldn't change anything. So we have to change it. So instead of using here the 0.05, I will just use speed x. And let me remove this comment. Okay, so now the speed x will actually change the way it works, and also we have to make sure that we save the code. If we won't save the code, it will think whether we are still using the 0.05. Okay, so if I'll just control Z for a second here. Okay, so look what happened. I did it quite fast, but I had this right. I changed this. Okay, let's go one more. Okay, so we were in this situation, and what I did is I deleted the comment, and I said instead of using 0.05, let me just use the speed x we created, right? And this looks great. We expect the speed x to affect the way that it moves, but I haven't still saved. So you still see this in yellow. This is how it looks on when we use Visual Studio Editor. This is still yellow, which means that the code hasn't been saved yet, which means that the code that is saved on the disk still has the 0.05. So in order to change it, I have to save it with either Ctrl S or using this button right here. on the left upside of the ID. So now we save it, and now it actually will affect the speed. So the speed here now is really high, so it will move really fast. Let's try the other way around. So I'll put like 0.0 and 0.2. So this is a really small speed, right? And if I run it, okay, you see it moving really slow. Now I can actually change it while it's running, and it will change because it always takes the number from this parameter. So this will work. I can also do something really interesting, because what happened is that on each frame we take that 0.002 and add it to the x, and that's the way we make the movement. That's why this is the speed. But what happened if I actually did something else? Let's start with 0.05, run it again. Okay, and this works really nice, but what happens if I change it to minus? So I put minus 0.05. Minus 0.05 means that it will actually add minus 0.05, which means that we, instead of adding to the x position, we actually subtract the speed. We not subtract, we add the speed, but because the speed is negative, we subtract from the x, and it actually makes it move it to the left. So this is the way we can actually change the direction of the movement. Okay, so this is pretty nice, but let's do something else. If we want to control the direction of the movement, let's just set the direction. So in order to do that, I'll do something like this. I'll do tab public, float, I'll still use float number, and I call it dir as a short of direction. And I'll put it now for 1f. 1f will change nothing. So if I'll put here, we have this thing, and we'll put just dir times position x. So as long as it's 1, so it will be 1 times the speed, it will have the, okay, so it has to be here. If we want to multiply the speed, let's do it here. So speed x times dir. So as long as it's 1, we'll have the same thing. So if, for example, we had the position 0 and we added 0.05, this is what we had before. Okay, then it will change the x position with the 0.05. Now if we multiply the 0.05 with 1, nothing will change, we'll get the exact same result. But if next we'll change the d to -1, it will actually go the other way around. Now because we made this variable as public, we can also see it in Unity and change it. So now if we go back to Unity, okay, we have here the dir, the direction, and if I press play, for now it's 1, so, but the speed is negative, so it's going that direction. Let's put it back to positive 0.05. When we run it, okay, it will go to the right. Now if we change it to -1, it will start going to the left. Okay, you see, so just by adding two variables, we can actually see a lot of changes in the behavior just because we're using different values. We're using different value of speeds, so we can move it look faster or slower, and we use the direction, so we can make it move to the right or to the left. So let's do something else. So one of the very obvious things we see now, that if we run like this with 0.05 and 1, that it goes and it gets to the wall, but it continues to move. And we actually want it to start before the wall, right? Because we don't want the pad to go outside of the screen. How would we do that? So what do we actually want to do? If you think about it, we want to ask each time before we move the pad a bit to the right, we want to see if it reaches the wall. And if we want to translate this thought into code, we have to think, what does it mean for the pad to reach the wall? What does it mean the pad to reach the wall? It means that it is in some position that it shouldn't move more to the right, because it's in the most it's in a position that the x is too close to the right wall, right? So how can we do that? So let's go back to the code and do something else. So here we actually change the position. here we actually change the position. Okay, so this is changing the pad position. Okay, so let's say that we want it not to happen before we reach the wall, and the wall can be represented by a position of x. So let's say if the position dot x is smaller than 3, for example, then in this situation, and I put 3f to make sure that it is recognized as float. It's very important. So as long as x is smaller than 3, then it should move to the right. So we've already had a look on if statement, and this if statement is no different. We have here the question, which is the answer is either true or false, either it's yes or no. And the question is, did the x pass 3.7? So if we started from 0 and moved to 0.05, and then on the next one we go to 0.01 and so on, at some point it will reach, for example, 2.95. 2.95 is still lower than 3, so it will still go inside and run the scope and move a bit to the right. And then next it will be 3.00. And of course 3.00 is not smaller than 3, so it will not go into here, and the thing we'll see in the game is the pad will stop to move to the right, because it will come here, we'll see it is no longer smaller than 3, so it wouldn't go and change the x position. So let me save it and let's see how it works. So if we go back to Unity and we just run the game, we should see the pad going to the right and stop before the wall, right? Now here's the kicker. It moves, but actually moves over, it still passed the side of the screen, but it stopped here on 3, because here the position is, it's got to 3.039, because it's added the speed and it wasn't exactly on 0 to begin with. So if we make sure it's, for example, starting 0 and run it again, we should see it stopping exactly in 3. Okay, so maybe not exactly in 3, a bit after, but the thing is that this is not what we wanted. We wanted to stop before the wall. Okay, so let's think how we can change it. First of all, again, if you remember what we said before, this is a literal number. We have literally the number 3 here, and we don't want to use literal values. We always want to use variable. So instead, we have here the public float speed, the public float dir for direction. Let's add public float, and we call it limit x. Okay, and limit x, and you know what, I won't put the value here, I'll just use it outside and I'll put it here. Okay, so I'll just use it here, limit x. So as long as x is smaller than limit x, I'll let it move to the right. Okay, in the same way. So now if we go back to Unity, we have the lim x here, and we can change the value. Now, to which value do we want to change it? We've seen that 3 is too much, maybe we should change it to 1.5, for example. So let's run it. We have some compiling issues in the console here. So if you try to run the game and get an error, you can just double click it and it will show you the code, but this is actually okay, let's just try to run it again. Okay. Okay, so this sometimes happens when you have this kind of strange error. Let's see if it has something here, and updates. So what I'll do now is just pause the video for a minute, and I probably will just reopen Unity and it will solve it. Okay, so I reopened Unity and let's have a look once more. And now when I run, again the pad moved, but moved to this position. So you can go back and forth and try to find the exact position, and there are better way of using some mathematics to calculate the exact position we want. But actually one of the best and easiest way to get a good solution for now is just check the X position when this pad touches the wall. So I'm just moving it to the right for now, and you can see it actually touches the wall in about 2.00, 2.01. So if we actually change the limit to 2.00 and move it back here and run it, then it actually moved and touched the wall and just stopped, and this is what we wanted to achieve. So in the next video we'll have a look on how to make it move to the other side and stop by the left wall and go back to the right and to the left. And this is a really basic way to control the movement of the pad. So we'll see how to do it in the next video, and the next step after that will be to actually control the movement of the pad through using the keyboard. Okay, so thank you very much for joining me. I'll see you in the next video.